Lesson is over volume of prisms and cylinders, which is what I have in the red box here. V equals BH. Capital B means area of the base, and H is the height of the prism or cylinder, which is the distance between the two bases. Now, because of that, capital B, area of the base, that each formula is different because it depends on the shape of the base. So a rectangular prism, the base is a rectangle. So for area of the base, you do length times width. So instead of capital BH, it's really length times width times height. For a cylinder, instead of capital B, cylinder's base is a circle. So you put area of a circle instead of capital B, which is pi r squared, and then H. Now, a regular hexagonal prism, these are just some examples. You have to be able to plug in whatever area formula you have. But instead of capital B, to find area of a hexagon, you do 1/2 perimeter times apothem, and then times the height. So you have to be able to change that capital B depending on what your base is. Okay, so find the volume of the prism. So remember, this is capital BH, where capital B is length times width. So we do, if you want to do the bottom as the base, you would do 13 times 3 times 5. Multiply all those numbers together, and you should get 195. Find the exact volume of the cylinder. So exact means you leave pi in your answer. So we have capital BH, but if the base is a circle, you do pi r squared. So volume equals pi, the radius is 8, because this is diameter, 8 squared times the height, which is 10. So 8 squared is 64, 64 times 10 is 640. Pi should be your final answer. 640 pi. All right, so volume of a trapezoidal prism, still going to be the same formula, but area of a trapezoid is 1/2 base 1 plus base 2 times the height. Now, these are two different heights. This one is the height of the trapezoid, and this one's the height of the prism, which is the distance between the bases. So let's do 1/2. The two bases are 3 and 7 for our trapezoid. 3 plus 7. The height of the trapezoid is 3.5. And then that's just this capital B. Then we need the height of the entire thing, which is the distance between the bases. So if the bases are the trapezoids, the distance between them is 6 right here. So multiply all that together. Let's see what you get. 105. Okay, this one's tricky. So volume equals capital BH, where capital B is area of a hexagon, so it's 1/2 perimeter times apothem. So let's just go ahead and do 1/2. The perimeter of our hexagon would be 9 times 6, which is 54. I'm going to leave this blank for the apothem and come back. And then it says the height of the prism, which is 12. So if the apothem, or if all the sides are 9, then half a side right here would be half of 9, which is 4.5. Now if you remember, on a hexagon, it's a 30, 60, 90 triangle, so you just multiply by radical 3 to get this. So even though you're not supposed to put a decimal in front of a radical, it doesn't really matter because you're just going to plug it in and type it all in. So 4.5 radical 3 is your apothem. Anytime you have a hexagon, it's going to be half of one side times radical 3. So if it were 8, it'd be 4 radical 3. If a side was 20, then the apothem would be 10 radical 3. You just half it and multiply it by radical 3. So if you type all that in your calculator, you should be getting 2,525.3. Okay, so this is our PAV 123 again, which we'll talk about in a separate section at the end. But perimeter over perimeter reduces to the scale factor to the first power. Area is reduced to the scale factor squared. And now we're doing volume, which reduces to the scale factor cubed. So if everything is tripled, that makes our scale factor 3. So the difference in the volume would be 3 cubed. So when you cube 3, you get 27. So the volume would be 27 times bigger. Or it might say that it's a ratio of 27 to 1. No, it says 27 times bigger. That's fine. Now, let me see what we have left. Okay, to find the exact volume of the cylinder, you'd leave it in terms of pi. I'd like you to pause this and you try this one, but I'm going to go ahead and solve it. So volume equals pi r squared h, if you plug pi r squared in for the capital B. So pi 24 squared times 33. Ooh. Okay, sorry. Let me go ahead and multiply these in and then I'll explain it. So 24 squared times 33 gives you a volume of 19,008 pi. But that is in cubic inches. Now, we could have changed it to cubic feet at the beginning if I would have read the problem better and seen that that's what we wanted. But now, if we're going to change it, we have to convert it to cubic feet. However, you can't just divide this by 12. You have to divide it by 12 cubed. Because remember, volume changes by the scale factor cubed. So if you divide that by 12 to the third power, you should get 11. So the volume is 11 pi. Now, it might have been better to just convert it in the beginning and then you wouldn't have to worry about it. So if you want to try that, just divide, like 24 divided by 12 gives you 2 feet for this. And then 33 divided by 12 gives you 2.75 feet for the height. And then it would give you 11 pi in the end. Might be easier that way, but it's up to you how you want to solve it. Just, most people will divide by 12. You just got to be very careful that you know that if you divide volume, you got to do it by the scale factor cubed. All right, so volume of composite figures is actually easier because you don't have to worry about what's on the surface. Like this is just going to be the volume of the triangular prism plus the volume of the rectangular prism to get the total. So let's see if I can, it says round to the nearest tenth. So let me move this. Maybe if I can. So the volume of the rectangular prism, I'm going to do that first because it's much easier. It's length times width times height. So you do 8 times 4 times 5 and get, let's see, 8 times 4 times 5 is 160 because it's length times width times height. Now the triangular prism is going to be a little bit trickier. Triangular prism, remember all prisms are capital B times H, but capital B for a triangle base is 1/2 base times height of the triangle times the height of the prism. So we have 1/2. The base of the triangle is 8. We don't know the height. I'm going to leave that blank. Then the height of the prism is the distance between the triangles, because it's the distance between the bases. So the distance between the triangles is this part right here, which is 4. Now to get this is kind of like what we did with the hexagon. We have 8, but we cut it in half, so we have 4 and 4. And this also makes 30, 60, 90 triangles, so you multiply that by radical 3, and you get 4 radical 3 for the height. So I'm going to multiply as much of this as I can. 1/2 times 8 is 4. 4 times 4 is 16. 16 times 4 is 64, I believe. Let me just check that. Yes. And so we have 64 radical 3 for the triangular prism. Now I know it said to round it, but I don't want to round it till the end. This thing keeps making random marks. So when we add the triangular prism plus the rectangular prism, let's see, plus 160, I got 270.9. Yay. Whew, and that is a little bit of work. All right, now this is a cylinder. I think this is the last one we're doing. So it says find the exact volume of the composite figure, which would be, oh, I don't know what I did. Sorry. I think I zoomed up. That's too big. Oh my. Okay, let's try that. So we're on this one. So we need the volume of the big cylinder, and because it's a hole cut out like a donut, we subtract the small cylinder. So volume of the cylinder is pi r squared h. So for the big cylinder we get pi 18 squared, the height is 12. So 18 squared times 12 is 888 pi. And then the volume of the small cylinder is going to be pi 9 squared 12. 9 squared times 12 is 972 pi. So we just end up doing 3,888 pi minus 972 pi, which 3,888 minus 972 is 2,916 pi, and hopefully that's what we got under here. Yay. And that's it.